Hello and welcome back to the new season of 5 Minute Geography. However, this season we're going to focus on leaving cert geography and getting those all-important H1 answers by explaining as simply as possible the world around us. So whether you're a student gearing up for the exams or a teacher looking for extra resources, you're in the right place. So subscribe to stay updated and let's tackle this course together.
I just want to go over today in this class, we'll start with a reminder of what we've done. We looked basically at the layers of the earth and we put new leave insert language, if you like, on top of it. So core, we changed the inner core, outer core. Mantle, the new words, the asthenosphere, the liquid part, and the lithosphere, the more rigid part. And then finally the crust broken into continental crust and oceanic crust. And we looked at both crusts in terms of its age, what it's made up of, its depth, and we discovered that the continental crust is stronger, younger than the older, heavier oceanic crust. Then we went on to look at the movement of these plates, the movement of the oceanic crust and the movement of the continental crust, and we looked at a thing called convection currents, and I showed you a quick video on that, and seafloor spreading. Now seafloor spreading is the thing I showed you with the two desks. So it's kind of like if you cut into a tree, the sap comes out of it to try and weld that tree back together. So it's the same idea. So convection currents and seafloor spreading. We looked at both in detail in the last day and I showed you this video. Now this video is going to be available. So that was the homework that you had to do. You had to look at the movement of, or the processes, of movement. And as a result of this process of movement, whether it be convection currents or seafloor spreading, we have plates moving in three different directions. They can converge or move closer to each other and hit off each other. They can diverge, meaning they can pull apart from each other. And finally, they can be passive or conservative. Another word is transform faults, which means they slide past each other. Now, in sliding past each other, they could be going in the same direction. So the two plates could be going in the same direction, but one could be going faster than the other. And this causes a buildup of pressure. And we're going to have a look at that when we look at the North American plate and we look at the Pacific plate, where the Pacific plate and the North American plate are going in the same direction, but one is going faster. And I just wanted you to have a quick look at these plates. So there are 7 major plates. Now there's loads of different smaller plates, but there's major plates, and you can see by the arrows, you can see whether they are divergent, so pulling apart, or convergent, hitting off each other. So the Nazca plate here is an oceanic plate, and it's colliding into the South American plate. So we have an oceanic plate and a continental plate smacking off each other. That's why we have here the Andes. Okay. Now, we know that the Nazca plate, being an oceanic plate, is heavier and weaker, and so this plate will subduct under the continental plate. Let's have a look here closer to Ireland. We have this long line here is called the Mid-Atlantic Ridge, and this ridge is being pulled apart from North America and Eurasia and Africa. So it's a divergent plate, and right smack bang in the middle of that you have Iceland. And Iceland is still growing today at a rate of about 2 to 3 centimeters a year, which is the same rate as your fingernails grow. So we have a divergent plate, we have a convergent plate, and up here we have a transform fault, or a passive plate, where the Pacific plate is moving in a north direction, as is the North American plate. So it's kind of a northwest direction. Both are moving in the same direction, but one is moving faster than the other. And right down here you have a tear in America, and we call this tear the San Andreas Fault. If we look here at India is colliding with the Eurasian plates, and we have the Himalayas. Africa, believe it or not, is still colliding towards the Eurasian plate. And we have here, don't forget, our mountains, which are the Alps. This is a video that's also available on the Google Classroom. What it is explaining is the idea of the theory of plate tectonics and Alfred Wegener's theory of Pangaea and Gondwanaland. The whole idea of continental drift was brought by this man in 1912, a man called Alfred Wegener, and he suggests that the continents were once joined together in one supercontinent, and he called this supercontinent Pangaea. He said 200 million years ago there was one landmass named Pangaea, one landmass and one ocean. He then suggests that around 130 million years ago, Pangaea broke up into Laurasia and Gondwanaland. Now, in order to prove this, he had a few observations. And here are the observations. His first observation was that the globe and the countries and the continents around the globe look like they fit together like a jigsaw. He used South America and Africa as examples. So I'm just going to quickly pop back here and have a look. He suggests that South America slots in here nice and neatly. He used a couple of other examples where he was able to bring the Australian plate around and it would fit snugly in here, and there was a few ideas where he was able to fit these plates, if you like, together like a jigsaw. So that was his first observation. Now, modern day techniques were able to go down in submarines way down into the land masses under the sea, and at a depth of about 1,000 meters we were able to map out the edges of these continents, and as they were mapped out we were able to put them together and they fit together almost perfectly. The reason why they don't fit together perfectly up over the ocean is because weathering and erosion is breaking down the land masses. But 1,000 meters below sea level, they fit together almost like a perfect match. His second observation was that South America and Africa show evidence of glaciation, and therefore the continents must have been somewhere else. For example, they must have been further south, closer to the South Pole, in order to have glacial ice. Ireland is the same. As glaciers move over land, they scratch the land in such a way they're called striations, and these scratches mark out the direction in which the glacier is coming from or going. So there's a lot of evidence left behind from glaciers. And South America and Africa must have been somewhere else if there was glaciers. Ireland as well is a good example. In Ireland, the major rock we have in Ireland is a rock called limestone. Now, limestone is made or created in subtropical shallow waters. Now, the last time I checked, Ireland wasn't in the tropics. So therefore, Ireland must have been somewhere else when that limestone was being created. His third piece of evidence was animal fossils. Excuse me. Animal fossils. So Mesosaurus bones were found in rocks in West Africa and in the east coast of South America. So therefore those animals must have been able to walk around there. They wouldn't have been able to cross those massive oceans. So animal fossils, the exact same animal fossils found in rocks, and at the same time the exact same plant fossils were found in rocks in South America and matched those fossils in the west coast of Africa. He also checked the rock type. So there was the same rock type, not only was there the same rock type, but they were the same ages and they were found on both of the coasts. So those rocks were formed at the same time in the same place. However, if we looked at them now, we'd say they're on two different sides of the world, so therefore they must have been together at some stage. And finally, he looked at mountain ranges. Fold mountains, when they occur, they fold in a certain shape or in a certain direction. He used the Caledonian mountain building period. In Northern Ireland, Scotland, Scandinavia, all those folds matched up with the Appalachian Mountains of the USA, when the USA and Europe were together at one stage. So he was able to match the folds and the bends of those mountains in Northern Ireland, Scotland, Scandinavia, to match them up with the USA. So those were his 6 observations. Now again, this is still a theory. The idea that Pangaea broke up into Gondwanaland and Laurasia and continued to break up and move today. The idea is that here we have present day, the idea that they're still going to keep moving and banging into each other and creating new land and destroying land, that in another 350 million years' time, we're going to have that supercontinent again, and the theory is it'll be Pangaea 2, where the continents smash together to create one supercontinent. So this was the idea that Alfred Wegener had, where it was a jigsaw fit. They fit together like a jigsaw, and he was able to match up the glaciation, stratations, the ice sheets, the mountains, to support his proof. Now, those were all theories. Now we can test these theories with modern day technology. So, in order to prove seafloor spreading, we've done the following. In the 60s, when we were drilling for oil in the Atlantic seabed, rock samples were taken up from the seabed, and it was discovered that rocks became older as we got closer to the United States and as we got closer to Europe. So the older rocks were the closest ones to the United States and Europe. The rocks actually got younger the closer you get to the mid-Atlantic ridge. And that's because rocks are basically being born in the mid-Atlantic ridge. We know that the ridge is pulling apart, and as it pulls apart, lava is extruded through those cracks and crevices and makes new rock, because the lava hits that cold water down in those depths and turns into rock almost instantly. So in the middle, where the Atlantic Ocean is splitting, the seafloor is splitting, new rock is being formed, which is pushing older rock away from the center. The older rock is closer to the United States and Europe. And that proves to us that the seafloor is spreading on both sides of the Atlantic. We now used satellites, a satellite ranging laser. And I'm going to look at this in the next video, because I've only 15 minutes to record this and it's coming up to 14 minutes and 20 seconds. So I'm going to be uploading, if you go into video 2, we're going to have a look at satellite ranging lasers.
If there's a particular topic you'd like covered or something you're struggling with, be sure to drop it in the comment section below and I'll aim to cover it in future videos. So subscribe to stay updated and let's tackle this course together.